Lesson 1-5, Solving Inequalities. So basically, we're going to follow the same steps as if these were equations. But the difference is they're not equal. They are either greater than, or in some cases less than. So after we solve these, we will then have to draw a number line and identify where our answer is on the number line. Okay? But it's going to be very similar to what you did before. So we're going to start with distribution. Distribute 2, distribute 2. You get 4x minus 8. Okay. Then if I'm going to solve for x, I'm going to do inverse operations. I'm going to move the 8 over. So now the 8's cancel out. And I get 4x is greater than or equal to 10. Okay, then we're going to divide by 4. And when you divide by 4, I get 2.5 or 2.5. Okay, so that's the answer. Now, on a number line, let me move this up. On a number line, you don't have to put 0 in the middle. I would recommend putting like at least 4 numbers. You're identifying where this point is. So this point would be at 2.5, which would be like right there. So I'm going to put a circle here. Now, there's a line underneath it. So that means when there's a line, this is x is greater than and equal. So if it's equal, we color in our circle. And because it's greater than, we draw an arrow going in this direction. So that's the answer. So what is x? X is every number greater than or equal to 2.5. So here's the thing. 2.5 is just the first answer. 2.6, 2.7, 2.8, 2.9, 3, 3.1, 3.2, 3.3, all of those are answers. And that's how you identify all the answers are on this side. Okay, next. We're going to distribute here. Negative 3, negative 6x, minus 6. Okay, we're going to have to move that 6, so the inverse of subtracting is adding. 6's cancel out. Negative 6x is less than 18. Okay, now this is where you have to be very careful. We're going to divide by a negative number. Now, when you divide by a negative number, the rule is the signs switch places. And here's what I mean. This was a negative and that was a positive, right? But when you divide with negative 6, the negative and the 6 cancel out. Now you're just left with an x, a positive x. Over here, 18 divided by negative 6 makes that a negative 3 now. So the signs, this was on the negative and this was a positive, but now this is positive and that's negative. So you switch signs. When that happens, this sign must flip. And it has to go the other way. So this is the answer. X is greater than negative 3. So now for the number line. Now this number line has to be on the negative side. So negative 1, negative 2, negative 3, negative 4. Okay? So those are my numbers on my number line. The circle that I draw is going to go on negative 3, but I am not going to fill it in. There is no line. It is not equal. It is just greater. So you leave it as an open circle. Okay? So open versus closed. And then this also says x is greater. Now greater is to the right. So I wouldn't go this way. These numbers are actually smaller. Negative 4, negative 5. The numbers I want are going this way. So my answer is negative 2, negative 1, 0. Your answers are all the numbers that are greater than negative 3. So guess what? Negative 3 is not the answer. But negative 2.5, negative 2, negative 1.5, negative 1, every number greater than negative 3 is your answer. So just be careful with these, okay? Okay, next. Okay, we have x's on both sides. So I like to move the smaller one first. So I'm going to move 2x over here. I'm going to get this. Okay, now I'm going to move that 22. Inverse of subtracting is adding. Because I want the x by itself. Remember, now that I have the x's together, the only thing I want on this side is x. Now negative 5 plus 22, that's going to give me 17. Next, I'm going to divide. So I'm going to divide by 3. 3's cancel out. I am not going to switch the sign because I'm not dividing by a negative. So the sign and x stay the same. Over here, though, I'm going to get a decimal. I'm going to get 5.6 repeating. Okay, so what about the number line here? Well, your number line in this case, let's go. I don't have to start at 0. Actually, I can go like this. I can start at any number I want, actually. You can start any number you want. So 5.6 is going to be somewhere right here. Now, actually, if I wrote this as a fraction, that would be 5 2/3. So let's see, 1/3, 2/3. It'd be right here. And then I would ask you, do I shade it in? Do I leave it open? Or sorry, do I close it and shade it in? Is it equal? Or do I leave it open because it's not equal? I leave this open. I don't shade it in. There's no line underneath it. But now, this is interesting. What does this answer say about x? X is what? X is greater than 5.6. Guys, you're answering for x. You're not answering for the number. I want to know what x is. X is greater. So greater is this way. If x was less than, then I would go the other way. Always read your answer. What does it say about x? And that's how you should shade it. Okay, next. All right, here, same thing. I'm going to distribute. I'm going to go a little faster. Right, and then this will become positive. Okay, now here, if I move 8x to this side, cancels out, I'm left with this. Now, before, I would ask you, is 4 equal to 4? The problem is, this is not equal. This says 4 is less than 4. That does not make sense. 4 is not less than 4. This is a no solution. It has to make sense. It has to be true. And this is not true. The next one. Okay, distribute here. Negative 6x, negative 3. Negative 6x minus 5. Okay, move the 6x. 6x's cancel out. Okay, again, you're asking yourself, is this less than? So I'm going to go back to vertical for a second. 0, negative 1, negative 2, negative 3, negative 4, negative 5. Which number is higher? Negative 3. So that would mean that negative 3 is bigger than negative 5, right? This number is higher, so it's bigger than negative 5. What does this say? Negative 3 is greater than negative 5. Because remember, on your number lines, this number on the right side is bigger than this number on the left side. So this is true. So this is a infinite solution. Infinite solutions. All right, last one. A word problem. So let's read this out. So we have two florists. We have florist A and a florist B. And the florist A charges $4.75 per rose plus a delivery charge of $40. Florist B charges $5.15 per rose plus a delivery charge of $25. So I would look at this like, oh, wow, I'm going to save $15 just on delivery. But they want to know, when will A be less expensive than B? So here's how to explain it. When is this option less than that option? When will this be less than? So I want to write an inequality to represent the situation. So $4.75 per rose, I'm going to put R for the rose, plus 40. Okay. Here, $5.15 per rose plus 25. And I want to know, when is this going to be less expensive, less than this one? That's the question. They want to know when will that be the case. So we're going to solve for R. Inverse operations, I'm going to move this one. This is the smaller one of the R's over here. So I'm subtracting. Cancels out. I'm going to be left with 40 over here. 25, 40 cents difference. I guess it's not that different. Yeah, not that different. Plus 25. Okay, I'm going to move that 25. Let me move this up, sorry. Let me move it up. Now I'm going to move the 25. Minus 25 to both sides. Minus 25 to both sides. That's gone. That makes 15. Okay, now I'm going to use Desmos. Actually, I'll use my phone real quick. Give me a second. I'm going to divide 15 divided by 0.40 because I want the R by itself. I want that. And I get this answer. So let me show you that. Okay, so what does this mean? This means you would have to buy 37.5 flowers for option A to be cheaper. Wait a minute. Half a flower? That doesn't make sense. I'm not going to buy like the stem and lose like the petals of a flower. No, no, no. In the real world scenario, that would mean you would have to buy 38 roses. 38. Because you wouldn't be able to buy a half flower from them. To make this the cheaper option, you would have to buy 38 roses. And if you bought 38 roses, this would be cheaper than this one. And that's it. That's the answer.